Hello, so this video is going to be about operating systems. Now, this is specifically for placement interested students. So it would be really good if you have somewhat knowledge about operating systems. We are going to discuss almost all important topics, but if you want to learn operating system in detail, then you may watch videos of KnowledgeGate or some other creator. I personally prefer KnowledgeGate, so you may watch his videos. So without wasting much of our time, let's get started with the operating systems. Our main focus throughout this series would be solving the questions, giving answer to all the interview questions. So it might go into a bit faster manner than covering all the detailed concepts. So yeah, let's get started with it. So first of all, let's understand why do we need OS? What's the need of OS? Now, हम say for an example fan का example लेते हैं, right? So if you want to turn on the fan, तो आप क्या कर सकते हो? फैन को खोलो, मोटर का सब कनेक्शन लगाओ, then provide electricity and the fan would start, right? But is that really feasible? No. So what we usually do, we introduce switch, right? Simple, on, off. So switch basically provides you the easy accessibility to use fan, right? Similarly, operating system is needed so that you can access the computer hardware resources without any problem. सभी लोगों को ज्ञान नहीं होता कि बैकग्राउंड में क्या चल रहा है, सभी लोगों को हार्डवेयर के बारे में पता नहीं रहता, तो हाउ टू मेक इट एक्सेसिबल टू ऑल पीपल. So that is done basically through operating system. So I hope the Y portion of OS is clear. Now let's understand what is OS. So as we discussed in the Y portion, OS is basically interface. Interface between what? Interface between user and hardware resources. So OS would provide hardware resources to the users. So I hope these two fundamental questions about why we need OS and what is OS is clear. Now let's move on to the next topic, which is goals of operating system. Yeah, so let's talk about goals. Now there are two goals. First one are primary goals and second is, of course, secondary goals. So if we talk about primary goals, the primary goal of the OS is convenience. I hope the spelling is correct. Then the other goal is accessibility. So these two are one of the not one of the, but these two are the major primary goals of operating system की सब लोगों को इस्तेमाल करने में दिक्कत नहीं होनी चाहिए. And when you provide that convenience, then we move on to the secondary goals, which are proper memory management होना चाहिए. ऐसा नहीं होना चाहिए कि there is too much of memory going to specific process. Say for an example, आप Call of Duty खेल रहे हो and Call of Duty requires a memory of, say for an example, 10 GB. So computer should provide just 10 GB or around that of memory, right? Now we will see how memory is allocated. Even 10 GB won't be provided, but this is just a vague example. So basically computer system doesn't need to give all 16 GB of your RAM to Call of Duty if it just needs 10 GB, right? So these are some of the secondary goals like memory management. Let me note it down. Memory management, then speed, then throughput. These are some of the secondary goals. Now let's move on to the next topic, which is functions of OS. Now, which are the functions of OS? Wait a second. Functions of OS. Don't mind my handwriting, I'm just roughing it up, I guess. But yeah. So let's move on to the first function. Okay, let me just give you an example first. Now, if there are, say for an example, you have Viva going on in your college, right? So is it really feasible if all the students rushes to the evaluator and tell कि भाई मेरा Viva पहले ले लो, मेरा Viva पहले ले लो? That won't work, right? There should be proper management. Similarly, in computer system, there are various processes which needs access to certain resources. Now, if the processes will go by themselves asking for the resources, then it will get chaotic, right? Similarly, not similarly. So, because of managing the process, the first function of the OS is process management. So I hope it's clear why do we need process management And what it does is it runs and switches between programs. It runs and switches between programs. We'll clear the difference between program and process in a while, but right now just get the basic idea, the overview of all the functions of OS. Now for the second function, say for an example, if you go into a restaurant, right? You are two people, you went to a restaurant. Now the manager or the waiter over there, would he or she assign you the table for 20 people? No, right? He or she would assign you for a table for 2 or a table for 4 people, right? Because 20 wala bana hai bade group ke liye. So there is no need to give you that much amount of space, right? The concept of fragmentation is related to this. We'll talk about this in the later portion. But yeah, so basically आपको उतना ही रिसोर्स देना चाहिए जितना आपको जरूरत है, राइट? आपको उतनी ही मेमोरी मिलनी चाहिए. सिमिलरली व्हाट आई टॉक्ड अर्लियर, प्रोसेस को उतनी ही मेमोरी दो जितनी उसकी जरूरत है. सो द सेकंड फंक्शन इज memory management. I hope it's clear what's memory management. So what will it do? It will allocate and isolate the memory. Allocate and isolate the memory. Now for the third function, let us talk about a librarian in your college or hostel or wherever. So what would a librarian basically do? He would put all the books in a single rack, or he or she would put the books according to its genre or according to its concepts or topics or subject. Of course, it would put according to the branches, or basically a system would be there for dividing the books, right? So similarly, in operating system, we need file system. File system will manage कि कौन सी फाइल कहाँ पे रहेगी, कैसे रहेगी. So third function of operating system is file system. File system, yeah. So what would a file system do? Well, it will manage files and folders. Okay, let's move on to the fourth function. Fourth function is device management. अभी आपके पास लैपटॉप है, then you would decide what to do with the laptop. You would manage all the tasks which you want to do the laptop. और टीवी है तो आप रिमोट का बटन प्रेस करेंगे, right? Similarly, operating system also needs a device management. What will it do? आप टीवी के रिमोट से क्या करते हो? टीवी को कंट्रोल करते हो, right? Similarly, device management would control the hardware devices. Control hardware devices. Okay, now fifth one is, okay, now I don't need to give you the example for this one. Security. It is self-explanatory. It will perform the operations which are required for the security. Sixth is, wait, I forgot. Yeah, user interface. Again, I don't need to explain what is user interface. You might be using MacBook, Windows, or Android or iOS. So those are basically user interface. It would connect the user to the system. And the last function of the operating system is CPU scheduling. We would learn major scheduling algorithms in the later portion. बहुत कुछ later में करेंगे. But yeah, basically it will schedule कौन सी process कब जाएगी, कैसे जाएगी. So that would be done by the that is the function of operating system, which is CPU scheduling. So these were some of the major functions. Now let's move on to the next topic, which is components of OS. We won't discuss about each and every components in detail, but we would just discuss about the major components, and one of them is kernel. Okay, let me write it properly. Yeah, kernel. So you would hear this word majority of the times when you are talking about operating systems, and it is one of the major component of OS. We can say that kernel is heart and brain of OS. So kernel will do the majority of this stuff. बाकी components को भी काम usually assign करा जाएगा through kernel or by kernel. So how does kernel work? Well, it gives kind of an interface between application and CPU resources. So let's show you with a diagram. So basically these are, oh wait, I suck at drawing. Yeah, these are your applications. So what kernel will do, it would reside somewhere between here. So this would be your kernel. And here would be your hardware resources like CPU, yeah, internet. Yeah, we are back. I'm so sorry. So kernel, yeah. So this would basically provide the interface between hardware and applications like CPU, memory, and devices basically. So yeah, that's basically what kernel will do. Now, another component of the operating system is, okay, I'll just note it down because we don't have time to go through each one of them. You just read it through any resources, you will get the idea. Process management. The third one is memory management. The fourth one is file system. The fifth one is device management. Sixth one is I/O system, input-output system. And the last two are security and user interface. Security. These basically align with the functions of the operating system. So if you are clear with the functions, then you'll get to know about all these components of the operating system. You don't need to worry about each one of them. Like if you have the basic overview of each one of them, then it would be better. क्योंकि यहाँ से I don't think so direct question कोई पूछेगा. You just need to have the idea about each one of these. Okay. Now one thing which you need to know is modes in OS. So what are the modes? User mode, and the other mode is kernel mode. Now user mode में basically क्या होगा? You will use the operating system or kernel to access the hardware. So we will use kernel. We can say that in a way, like it's not 100% factually correct, but we can say that. And whereas in kernel mode, we can directly access the hardware. So direct access of hardware. So I hope all these modes are clear, and दो ही modes है, and there is a concept of mode bit 0 and 1. So zero mode bit would be assigned when there is a user mode, and one mode bit would be assigned when there is a kernel mode. So that was about user mode and kernel mode. Okay, so let's talk about structure of this. Structure of operating system. So let's get started with simple structure. अभी simple structure में क्या होगा? I'll explain you through the diagram. सबसे नीचे ROM BIOS driver would reside. So down here there would be ROM BIOS drivers. अभी इसके ऊपर क्या होगा? MS DOS device drivers. अभी क्या होता है नहीं समझ आ रहा तो इट्स ओके, पापा से पूछ लेना MS DOS क्या होता होगा, बिकॉज इन द लेट 90s इन द अर्ली 90s देयर वाजंट प्रॉपर यूजर इंटरफेसेस, तो उस टाइम पे MS DOS सिस्टम थी, तो उस सिस्टम में एवरीथिंग वाज वर्किंग थ्रू कमांड्स. अभी आपको एक फाइल भी ओपन करनी है तो आपको कमांड रन करना पड़ता था. इट्स बेसिकली द थिंग विच वी यूजुअली डोंट डू. लिनक्स सिस्टम यूज करना लेकिन GUI नहीं यूज करना. That was basically MS DOS drivers. Not drivers, but that was the MS DOS system. So basically this system would be connected to ROM BIOS drivers. And above MS DOS drivers, there would be system programs or resident system programs. Now these resident system programs would be connected to MS DOS drivers, as well as these would be connected to ROM BIOS drivers. I hope it's clear. And above that there would be application program. Now as you might guess, क्या लिख रहा हूँ? Yeah, it would be connected to resident system program, and it would be connected to ROM BIOS drivers as well. So this is how simple structure would look. I'll show you the proper image of the same so you can get the clear idea. Yeah. This is how the structure looks. Application program, precedent programs, MS-DOS drivers, ROM device drivers. Okay, और वो MS-DOS वाला बोला, that was just an example of MS-DOS system. Don't consider it as MS-DOS drivers, okay? Don't mix it up. That was just information which I just remembered randomly. Now, second structure is monolithic structure. Monolithic structure. Let me just pen down the diagram of the same. You would have heard about this word in the system design as well as somewhere in cloud computing as well. Like you have modular design, you have monolithic design. Similarly, in operating system structures, there is monolithic structure. So in short, kernel में ही सभी के सभी components reside करेंगे. As you can see over here, file system resides here, memory management is here, process management is here, and other things as well. And ऊपर होगी applications. Now unprivileged mode बोले तो user mode और privileged mode बोले तो kernel mode. अब समझ आ गया होगा what are modes in operating system. And of course down here you have hardware. तो सभी का सभी काम का जो होगा वो हैंडल किया जाएगा थ्रू कर्नल. So in this mode there is one problem which is कि अभी एक ही इंसान सभी काम कर रहा है तो the throughput would be less, the speed would be less, but management somewhat complex होगा क्योंकि उसी को सब कुछ decide करना है. But it is simple to understand क्योंकि understanding complexity नहीं है, पर अगर आप कर्नल के point of view से देखो तो to apply this thing is a bit complex. So to like ये जो इसका limitation था उसको दूर करने के लिए we have got the microkernel approach. Microkernel approach. Let me show you the diagram of the same. So now we'll move a bit fast over here because these are not our major point where we need to focus. Like these are important things, but you'll get to know about these things eventually. So yeah, this is microkernel based approach. Now as you can see, जो भी important काम है कि इंटर प्रोसेस कम्युनिकेशन है, मेमोरी मैनेजमेंट है और सीपीयू शेड्यूलिंग है, सिर्फ ये रिसाइड करेगा कर्नल में और वी कैन से इट माइक्रो कर्नल. एंड बाकी जो एप्लीकेशन प्रोग्राम है, फाइल सिस्टम है, डिवाइस ड्राइवर, जो उतने इंपॉर्टेंट नहीं है कि कर्नल को खुद मैनेज करना पड़े, वो रिसाइड करेंगे आउटसाइड ऑफ द कर्नल. सो क्या होगा इसमें, स्पीड बढ़ जाएगी, थ्रूपुट बढ़ जाएगा. दिस वुड बी मॉड्यूलर डिजाइन. You can associate it with loose coupling because dependency कम हो जाएगी एक दूसरे पे. And the above one was hard coupled. Exam में मत लिखना it's loose coupling or hard coupling, but yeah, this was just to make you understand. Okay, उसके बाद आता है layered structure. So in layered structure, what am I writing? Yeah, layered structure. Let me show you the diagram for the same. So this may basically the name itself suggests there would be layers. So layer 0 would be hardware. Then similarly हार्डवेयर के बाद जो भी चीज़ें आती है वो बढ़ती जाएगी एंड वो नेक्स्ट लेयर से कनेक्टेड होगी. सो से फॉर एन एग्जांपल लेट मी चेंज द कलर. सो यूज़र इंटरफेस लेयर को अगर हार्डवेयर का कोई भी काम है तो इट विल नीड टू पास ऑन द मैसेज टू द नेक्स्ट लेयर, दैट विल पास इट फर्दर, दैट विल पास इट फर्दर. सो लेयर बाय लेयर काम का जो होगा, देयर वोंट बी, सॉरी देयर लिख दिस आउट, सो या there won't be direct access. So no direct access of hardware in this particular structure. So that was basically layered structure. The main point of discussing all this was to give you the basic idea about layered structure, hardware, microkernel structure, monolithic structure, and simple structure. So I hope you do have an overview about all this structure after watching this particular section. Okay, so now let's talk about multi-programming. Multi-programming. So the idea is कि CPU किसी के लिए भी वेट नहीं करेगा. अगर कोई भी प्रोसेस इनपुट आउटपुट के लिए गई तो वो दूसरी प्रोसेस को मेमोरी एलोकेट कर देगा, रिसोर्स एलोकेट कर देगा वाया कॉन्टेक्स्ट स्विचिंग। कॉन्टेक्स्ट स्विच बोले तो एक प्रोसेस के पास से रिसोर्सेस छीन लेने का और दूसरी प्रोसेस को वो रिसोर्सेस दे देने का, दैट इज बेसिकली कॉन्टेक्स्ट स्विचिंग। सो सीपीयू किसी के लिए वेट नहीं करेगा, जैसे ही कोई भी प्रोसेस बाहर गए इनपुट आउटपुट के लिए, दूसरी प्रोसेस को रिसोर्स अलोकेशन बाय डिफॉल्ट हो ही जाएगा, दैट इज मल्टी प्रोग्रामिंग। नाउ लेट मी मेक इट क्लियर कि मल्टी प्रोग्रामिंग में देयर वुड बी वन सीपीयू, ठीक है, और उस सिंगल सीपीयू पे मल्टीपल प्रोग्राम रन करेंगे बट नॉट एट द सेम टाइम। एक चीज अपने दिमाग के अंदर बैठा लो कि कंप्यूटर में ट्रू पैरेललिज्म होता ही नहीं है। इफ देयर इज अ सिंगल सीपीयू तो एक पॉइंट पे एक ही कामकाज किया जाएगा, पर वो कॉन्टेक्स्ट स्विच इतना फास्ट होता है कि वी फील कि मल्टीपल प्रोसेसेस एक साथ रन कर रही है, बट दैट्स नॉट द केस, ठीक है। सो यू नीड टू बी क्लियर अबाउट दिस थिंग कि मल्टी प्रोग्रामिंग में सिंगल सीपीयू होता है, मल्टीपल प्रोग्राम्स काम करते हैं सिंगल सीपीयू पे बट नॉट एट द सेम टाइम। एंड देयर इज वन मोर टॉपिक विच इज मल्टीटास्किंग। मल्टीटास्किंग पूछे कि क्या है, तो मल्टीटास्किंग इज मल्टी प्रोग्रामिंग विथ राउंड रॉबिन। फिक्स टाइम के साथ कॉन्टेक्स्ट स्विचिंग होता जाएगा और आपको ऐसा लगेगा कि आपको ट्रू पैरेललिज्म मिल रहा है, क्योंकि ये जो कॉन्टेक्स्ट स्विच है वो बहुत तेजी से हो रहा होगा। सो यू विल फील कि आपकी मल्टीपल प्रोसेस एक साथ रन कर रही है, पर दैट्स नॉट द केस। नाउ अनदर टॉपिक इज मल्टी प्रोसेसिंग। हियर वी विल गेट ट्रू पैरेललिज्म, पर कैसे मिलेगा? हियर वी हैव मोर देन वन सीपीयू। अभी एक से ज्यादा सीपीयू हैं तो एक टाइम पे एक से ज्यादा प्रोसेस चल सकती, दिस वुड बी ट्रू पैरेललिज्म। आपने सुना होगा कि 8 कोर सीपीयू, ऑक्टा कोर, हेक्सा कोर, 16 कोर। इसका मतलब क्या है? 8 कोर मतलब देयर वुड बी 8 स्मॉलर सीपीयू यूनिट्स और वो आठों के आठों अलग अलग प्रोसेसेस को असाइन किए जाएंगे, दैट इज बेसिकली 8 कोर। So that is multiprocessing. So I hope multiprocessing और multiprogramming में कोई दिक्कत नहीं है. Let me pin down the difference between multiprogramming and multiprocessing. Just a second. Yeah. Okay. So as I said, there would be multiple programs residing in the memory and execute one at a time by switching. और multiprocessing में there would be multiple processors or multiple CPUs. Goal of multiprogramming is increasing the CPU utilization, whereas goal of multiprocessing is increasing the computing speed and reliability. क्यों speed? क्योंकि प्रोसेसर ही ज़्यादा है, CPU ही ज़्यादा है, तो ऑफ कोर्स आप एक साथ ज़्यादा काम कर सकते हो। और इसमें क्या होगा? CPU यूटिलाइजेशन ज़्यादा होगा, क्योंकि एक CPU है तो उसके अंदर आप डिफरेंट प्रोसेसेस बार बार रन कर रहे हो। अगर कोई इनपुट आउटपुट पे जा रहा है तो आप दूसरी ला रहे हो, तो ऑफ कोर्स CPU यूटिलाइजेशन वुड बी मोर इन मल्टीप्रोग्रामिंग। As I said, single CPU, multiple CPUs. Execution, one program executes at a time. इसमें multiple programs can run at simultaneously. Efficiency, इसमें of course CPU utilization ज़्यादा होगा, same point ही है, और इसमें throughput और speed ज़्यादा होगी। Example, old Unix and MS-DOS system और multiprocessing में है basically सभी system आज की जो multiprocessing use करते हैं। And yeah, you can have multiprogramming and multiprocessing as well, कि जो different 8 CPU हैं या डिफरेंट से फॉर एन एग्जांपल 3 सीपीयू हैं और इसके ऊपर आप मल्टी प्रोग्रामिंग कर सकते हो। दिस इज जस्ट अ थॉट, इस पे ज़्यादा ध्यान मत देना। लेट्स जस्ट फोकस ऑन व्हाट इज मल्टी प्रोग्रामिंग एंड व्हाट इज मल्टी प्रोसेसिंग। सो आई होप इन दोनों के बीच में डिफरेंस क्लियर हो गया होगा और कोई डाउट नहीं होगा। एंड यार ये स्क्रीनशॉट ChatGPT का है। ओके, सो नाउ लेट्स टॉक अबाउट हार्ड रियल टाइम ओएस and soft real-time OS. Don't get naughty by seeing the word hard, but yeah. So hard real-time OS मतलब जो OS यूज होती हैं, say for an example एयरप्लेन में या फिर हॉस्पिटल्स में जो यूज करते हैं डॉक्टर्स while performing an operation. So इसमें क्या होता है that we cannot afford any amount of lag. 5 सेकंड के बाद ये नहीं बोलना चाहिए कि आप हार्ट के पास पहुंच गए, अभी आप कुछ काम काज करो उधर, जो भी काटना कूटना रहता है वो। and I don't know anything about medical stuff. Yeah, so basically that is hard real-time OS, जिसमें आपको कोई भी lag bear नहीं कर सकते. If there would be even a small amount of lag, that won't be bearable because that would cause a huge amount of destruction. That could lead to disaster. Whereas soft real time OS हम कहाँ यूज़ करते हैं? तो से फॉर एन एग्जाम्पल कि आप वीडियो कॉन्फ्रेंसिंग कर रहे हो, तो आपने देखा होगा कि कभी मैं बात कर रहा हूँ और हेलो ऐसे फटाफट फटाफट फ्रेम्स घूम जाते. क्यों? क्योंकि देयर इज नो नीड कि आपको एग्जैक्ट अमाउंट ऑफ टाइम पे ही डेटा आना चाहिए. या दूसरा एग्जांपल आप ले सकते हो गेम्स का. आपने गेम्स में देखा होगा कि पिंग आ रही है, 300 ms की पिंग आ रही है. पिंग क्यों आ रही है? क्योंकि these are based on soft real time OS because our priority is not to give you each and every information at that specific point of time. थोड़ा डिले होगा तो चलेगा. So those kind of systems is used where we don't need the exact information at the very specific time. So I hope it's clear the difference. So I hope the difference between hard real-time OS and soft real-time OS is clear. Okay, so that's it for this video. See you in the next video. Bye bye.